Okay, guys. I know last time we didn't do that one. Let me just try the last one, and then we're done. A lot of students was asking me that question. I done it on period 6 only. I know I didn't do it on period 1 and period 2. So let me do it very quick. So you should be ready for the exam. Just make sure to review the review packet and the exercise I did in class from the textbook. Okay. That question, they ask you to use the mathematical induction to prove for all integers, for all positive integers and any distinct real numbers x and y, x minus y divides x to the n minus y to the n. Again, let me repeat that sentence in case you saw it in your exam. X minus y divides x to the n minus y. Remember in class on the textbooks, I changed the question by telling you, let me write it down, x to the n minus y to the n is divisible by x minus y. That question and that statement and that statement are the same. Okay? Don't be confused if I change a little bit the question. But that statement are the same. Okay, make sure you want to do the same problem. So now here the base case. Go ahead for the base case. Choose x if n equal 1, so you have x minus y is divides, of course, divides x raised to 1 minus y raised to 1, which is true. And even if you go to 2, you can factorize. Okay, let's go to 2. Let me show you something. If n equal to 2, so here you have x square minus y square, okay? And x square minus y square, as you know, is just x minus y, parenthesis x plus y, okay? So you can tell here x minus y divides x minus y plus y, which is x square minus y square, which is true, okay? And you keep going, even you have x to n to the n equal to 3, okay? The base case is very fair now. Now let's do the inductive step, okay? Now, let's suppose for all integers positive, for all n integers positive, so we have x minus y divides x to the n minus y to the n, okay? We suppose this one now is true. Okay, now our goal is to prove x minus y divides x to the n plus 1 minus y to the n plus 1. Okay, here is our goal. Let's prove it. So what we know here is x n plus 1 minus y n plus 1 is x to the n times x minus y to the n times y. Okay. We can add and subtract here. We can add and subtract by x, y to the n, positive and negative, it doesn't matter. Positive 1, negative 1 is just 0. It won't affect the expression. x y to the n minus y and y. I didn't change anything here. I just add and subtract by this one. Okay, here I just add and subtract by this one. Okay, and nothing changed. This one is just 0. It won't affect this one. It won't affect the expression. The expression is just the same thing here. Okay, now let's go. So here I can factor, I can use this one and use this one. Let me check if this one will work. Yes, this one will work, and this one, it won't work. Yes, it will work. It will work. Okay, let's factorize here by x. If I factorize here by x, and let me factorize here also by y to the n. If I factorize this one by x, I will have x times x to the n minus y to the n. Plus, if I factorize that expression by y to the n, I will have x minus y. Okay? Now, I will have x to the n plus 1 minus y n plus 1. Okay? Now, since by assumption or by supposition, but by assumption, we know that x minus y divides x to the n minus y to the n. Okay, this one is done because we know this one divided by x to the n minus y to the n. This one also divided by x minus y, okay, to the n. So now, therefore, we can say x to the n, x minus 1, x minus y divides x n plus 1 minus y n plus 1 by mathematical induction 1. You have induction 1, induction 2, induction 3, and the only difference, mathematical induction 1, mathematical induction 2, and strong mathematical induction. The only difference is to go from induction 1 is a simple one. Mathematical induction 2 is when you have the inequality sign or you have divides. So here, since we have a divides, is induction 2. Okay? So here, by mathematical induction 2, for all positive integers, we can say x minus y divides x to the n minus y to the n, and that's it. Okay, that one is good. And another way also you can use also this one. Another way also you can use what you know about this one is, x. So here the best case, I suppose, is fine. Okay, best case, you can check the first one, the best case first. The best case is fine. I just want to show you the inductive steps. So the inductive step is when you go to n plus 1, xn plus 1 minus yn plus 1. Here, when we factorize, we can tell. Okay, let me show you something. So if you factorize this one, you can start here. Let's go x minus y times x to the n plus y x n minus 1 plus y square x n minus 2, and so on until you reach if y equal n minus 1 and you have x, and the next one will be y to the n. Let me check here. You have this one and you keep going. You have this one, it will grow. Yes, it's this one. Good. So you have this one now. Let me show you something just to verify if it's true. This one is equal to, if you try to distribute here, try to distribute the x first. X times x to the n is x to the n plus 1. And the second one will be y x to the n. And the third one, try to multiply the x by this one. You will have y square x to the n minus 1 plus, and so on. If you reach here, you will have yn minus 1 x square. And keep going, and here the last one, you will have y to the n x minus. Now you have negative y times this one. You will have negative x to the n y. And the next one, you will have minus y square x to the n minus 1. And the next one, you have y to the third x n minus 2. And the next one, you will have so on. And you reach here, you will have y to the n x. And this one, you will have minus yn plus 1. Okay, check it here. So here, you can tell, here this one will cancel out. Okay? And this one will cancel out. Everything will cancel out. This one is here, will cancel out. So on before we cancel out, this one also will cancel out. So what do we have left? The only one we have left is this one and this one. Okay? And make sure you put the negative sign. So we will have left x to the n plus 1 minus yn plus 1. So we can conclude here. We can conclude x n plus minus y plus 1 here, n plus 1. And you have x minus y times x to the n plus y x n minus 1, and so on. And you have yn minus 1x plus y to the n. So here, since we suppose this one is true, since by assumption we know x minus y divides x to the n minus y to the n, then this one divided by x minus x to the n minus y to the n. Therefore, we can say x minus y divides x to the n plus y plus 1 minus y to the n plus 1 by mathematical induction to, for all positive integers, x minus y divides x to the n minus y to the n. Okay? Just take your time and review it, and we're done. Good luck for your exam.